Today we are going to talk about a topic found within section 7.5, roots and zeros. We are going to talk about Descartes' rule of signs. Now, what Descartes' rule of sign tells me is how many possible positive real zeros I will have, how many possible negative real zeros, and how many imaginary zeros I will have. Now, it does not tell me what those zeros will be. It just gives me the number of how many possible zeros I will have that will be a positive number, or how many will be a negative number, or how many will be imaginaries. Now, to figure out the number of positive real zeros, what we're going to do is count the number of changes in the signs of the coefficients of the function f of x. Now that's the original function So we will just use the original function and simply count the number of sign changes. Now to figure out how many negative real zeros, what we first have to do is find f of negative x. So we're going to replace all the x's with negative x and simplify. After we replace all the x's with a negative x and simplify, then we simply count the number of sign changes again. Now, in order to find how many imaginary ones I'm going to have, what I will do will be I will subtract the positive real and the negative real from the total number of zeros. And that'll give me how many imaginary zeros I will have. Now, imaginary zeros, they must come in a pair. What that means is I need to have either 0, 2, 4, 6, etc. So an example, let's state the possible number of positive real zeros, negative real zeros, and imaginary zeros of p of x. So for positive real, we simply just work with p of x. So I'm just going to rewrite it for myself. So what I will now do will be count the sign changes. So that goes from positive to negative, so that's one sign change. This does not change. This is a second sign change. This would be a third sign change, and this would be a fourth sign change. So what that means is we could have 4 positive real zeros. Now, what we also have to do with this number is subtract 2 from it if this number is bigger than 1. So what this really means is I could really have 4 or 2 or 0 positive real zeros. Now we do the same thing, but to figure out the negative real, I do p of negative x. Now when I plug a negative x in for x to the 5th, that's going to flip signs because it's an odd exponent. When I plug it into 6x to the 4th, that sign stays the same. Plug it into 3x cubed, I flip signs. 7x squared, the signs stay the same. 8x, I flip signs, and 1's a constant, so it does not change. Count the sign changes again. 1. This time there is only 1, so that means that there's 1 negative real zero. Now what I will do is make a chart to figure out how many imaginary zeros I will have. So, now for possible positives, I could have had 4, 2, or 0. Negatives, all I could have was 1. Total in each will be 5. So then I can kind of backtrack. So if the first one's 4 positive, 1 negative, that means there's going to be 0 imaginary. The second one, if there's 2 positive and 1 negative, that means there's going to be 2 imaginary. And then the last one, if there's 0 positive and 1 negative, that means that there will be 4 imaginary. Let's try another example. Now we will be using the same directions that we did before. So first, for the positive real, I want to just check f of x. So 1, 2, 3. So that means that there are either 3 or 1 positive real zeros. Now for my negative real, f of negative x, when I plug in a negative x, I get negative x cubed minus 4x squared minus 6x minus 4. So when I count them, that means that there are 0 negative real zeros. So when I go to make my chart, positive, negative, imaginary, and total. Positive, there was 3 or 1. Negative, there was 0. And total, that there was 3. So that means I could have either 0, or 2 imaginary roots. So what's nice about this chart is by looking at this column, since there is 0 negative roots, then you don't want to test any negative numbers. Okay, you're never going to get a negative answer. Negative anything will never be your root, so don't waste your time testing it.